Okay. Next topic we're going to be talking about is making salts. And there are a lot of processes we need to look at. So reactions with metal hydroxides and acids, metal oxides and acids, and metal carbonates and acids. So the basics of neutralization is basically reacting hydrogen ions with hydroxide ions to form water. So if you're a neutralizing acid, you're trying to use up all of the hydrogen ions. If you're neutralizing a base, so an alkali, you're trying to get rid of all of the OH minus ions. So you can see from this equation, it's going to be hydrogen ions plus hydroxide ions giving you water. And that is the equation right there, H plus OH minus gives you H2O. Acids are neutralized by alkalis generally and bases, and this gives you salts and water. And that's like kind of the general equations that you're going to be getting. I want to emphasize this as well. If you are writing equations for neutralization reactions, the ionic equation is always going to be H plus OH minus gives you H2O. If it's a neutralization reaction, there is no other ionic equation. So that just makes it simpler for you to understand. So let's look into the three things that you can get, three different types of equations. First thing, it is the metal hydroxides and the acids. If you react a metal hydroxide with an acid, you're going to get a metal salt and water. That's the same thing with metal oxides. If you react it with acid, you're going to get a metal salt and water. And the only difference is that metal oxides, sometimes you do need to heat it up for the reaction to take place. But generally, the reactions will always give you a salt and is always going to give you water. Again, I say this, neutralization reactions always will give you an ionic equation of H plus OH minus gives you H2O, as you can see here. Now let's look at the neutralization with metal carbonates to produce salts. When a metal carbonate reacts with acid, you do get metal salt and you do get water. However, you also get an extra thing, which is carbon dioxide, is in the equation. A lot of the times in your exam, you're going to be getting these three different scenarios where they give you an acid, so usually hydrochloric acid like HCl, and they'll give you a metal hydroxide, a metal oxide, or a metal carbonate, and you have to figure out the equation. So just be wary of what you will get. If you have trouble deducing it, at least you can write water in one of your equations, and if it's a carbonate, at least you can write carbon dioxide in your equation to get some marks. And within this topic, you also have practical of soluble salts. So how soluble salts are made, essentially, they can be made from acids. And as I said, you can react them with any soluble, insoluble substance, metals, metal oxides, metal hydroxides, or carbonates. Now, the diagram on the right shows you the practical that you need to know extremely well, step by step, why you do each step, so that you'll be able to answer some of the questions you'll get in the exam. Because with this practical, it's producing soluble salts. This is what the practical is about. You need to be able to know what's happening in each step, and you need to be able to understand why. So I'm going to go through this slowly with you. First part, when you're producing a soluble salt, you have the acid, and you're going to add the solid into the acid and mix it until there are no more that reacts, basically until there is excess solid. When the solution is saturated, filled with the solid, adding more of the solid is not going to dissolve any further. That's when this solution is saturated. The reason you want to do this is you want to make sure that all of the acid in the solution has reacted. That's the reason you want to have this excess. You want to mix it and react it until it has excess solid. You want to make sure all of the acid has reacted. The second step, you're going to heat this solution until it evaporates a little. The reason you want to heat the solution is because you want the process, the reaction, to go quicker. You want to give it more kinetic energy. You want it to react a lot faster. That's the reason for step 2. Step 3, you're going to filter to remove any excess solid and leave the solution of the salt in some kind of evaporating dish. That's where you're going to get your salts. But the reason you're going to filter is so you can get rid of any of the excess solids that you've left in there. In a question, if it asks you why you want to filter it, you have to name the specific solid as well. I want to emphasize that. Final step, you don't need to really know the reasoning behind it. It's just you have the evaporating dish, you let it crystallize, and you're going to get your metal salts. You're going to get your crystals. And usually to evaporate any of the solution, you're going to either use a water bath or you're going to use an electric heater. Those two things. One of the two answers will be correct, so don't worry about that. I'm going to repeat myself again, explaining this experiment. because this is important. You're going to add the solid into the solution, into the acid, until no more solid reacts, until it's in excess. This is to make sure the acid fully reacts. Second step, heating it up until some evaporates. This is to make sure the reaction goes faster. This allows to have more kinetic energy and therefore it goes faster. Third step, filtering. Filtering any excess solid, making sure that there's not any little bits into the solution that you put into your evaporating dish. Fourth step is just waiting it to crystallize, and you evaporate this using a water bath or an electric heater. Those two things. I hope that was clear for everyone. So we're going to move on to a question. I'm going to just explain this because these are 1-mark questions. First question there, the potassium, telling you the neutralization of hydrochloric acid and potassium hydroxide. To be able to figure this out, usually I would write an equation. So you can just write out HCl plus KOH and you can figure it out. Because you know that neutralization, you're going to have a salt and water. So by taking out the OH from the hydroxide, taking the H from the acid, you're left with Cl and potassium. So that would just tell you that the salt is potassium chloride. That's the way you would think about it. That's the way you would process how you figure out what the salt is through the neutralization. Removing the H from the acid and removing the OH from the hydroxide. Whatever is left, that's going to be your salt. Second question, write an ionic equation for the neutralization of hydrochloric acid with potassium hydroxide. And I already emphasized this so much earlier. The ionic equation for neutralization will always, always, always be H plus OH minus gives you H2O. There's nothing around it. So those are the kind of the questions I wanted to look at. This question on the left and on the right, this whole page, the slide that you're seeing right now, is emphasis on the practical I just showed you. So it's asking you, give the reasons for these few steps in this experiment. Step 2, warming the sulfuric acid. Let the reaction go faster, as I've said earlier. So this is all just like repeat of what I said. Speed up the reaction. Step 5, repeat steps 3 and 4 until there's magnesium oxide remaining in the beaker, until there's excess solid in the beaker. Why are we doing this? To make sure all the acid has reacted. Step 6, why are you doing step 6? Why are we filtering the mixture? To remove any excess. And I've said before, if you're doing this in an actual exam paper, you have to specify what solid they are telling you. So instead of saying to filter the solids, you have to say remove and filter the excess. In this case, magnesium, I think was the thing? Magnesium oxide. Remove any excess of magnesium oxide. That is the solid you have to write to make sure you get the full marks. Final part, how should the filtrate be evaporated gently in step 7? Again, I mentioned earlier, there's only 2 things you would evaporate it with, either a water bath or an electric heater. So any of these 2 would be completely fine. So that would be the mark scheme for this question. So now I want you guys to actually try. Okay, so this is not in triple science, I believe. No, sorry, this is not in combined sciences. I think this is only in triple sciences when it comes to mole calculations. So if you are in combined sciences, I guess have like a 2-minute break. If you are in triple sciences, can you guys please attempt to do this question because it's quite hard, I would say. Sorry, my bad. I think combined sciences, you need to do this as well. I'm just realizing it's only concentration that you don't need to do. So attempt this question, please. Okay. I don't want to, let's just move on to the questions. Right. Here is asking you first to calculate the number of moles of iron used, right? So you have iron here. It tells you have 14 grams of iron. And in the 14 grams of iron, you also know that the relative atomic mass is 56. So the first thing I'm going to figure out is the number of moles of iron, right? And using the equation, moles equals, sorry, this is really hard to do, mass over mR. That is horrible. Right, maybe I should type this out. That's going to give you 14 divided by 56. That's going to give you the moles. And that's going to give you the moles of 0.25. That's iron. So that's the first step. Second step is asking you to figure out the number of moles of chlorine that react with the 14 grams of iron. Because we need to figure out the moles of chlorine, we need to look at the number in front here, the 3 and the 2. The mole to mole ratio here is 2 to 3. So instantly, I need to figure out what the moles are by doing dividing or timesing. So from that, I'm going to know that 0.25 divided by 2 times by 3 is going to give you 0.375 moles. That will be the moles of chlorine. Finally, now that I have the moles of chlorine, I need to figure out the volume that I need. I have been told that the volume of 1 mole of gas is 24. So to figure out the moles of chlorine, which is 0.375, I'm just going to do 0.375 times 24, which should give you 9. Ooh. It's not. This should give you the answer of 9. That's not. There we go. So the answer will be 9 decimeters. Any questions regarding this? I know I saw a few questions, like, is there any questions regarding the this question? This is a toughie. Seems like we're all okay. Okay. That is the mole questions. This one is just an example. There can be harder ones, especially for triple sciences. So everyone who is in triple sciences, and I mean even in combined science as well, please be careful of like these mole calculation questions and do as much practice as you can with this. Okay. Now we can. Okay.